Hey guys, today we're going to find the distance between a line and a point, and I have an example for us to use here. The line's equation is y equals negative 1/3 x plus 2, and the point that we're going to use is 5, 7. So this line has a negative slope down 1/3, I don't know, let's say it's this. Somewhere in that general direction. So there's our line, and we have this point out here, 5, 7. I'm not doing it on a true coordinate plane. And so what we're looking for is this distance. We're looking for that distance right there. Now, how do I know it's exactly that distance and not from here to here, or from here to here, or from here to somewhere down here on the line? Well, when we talk about distance between two things, without saying so, it's automatically the perpendicular distance. It's kind of like the shortest route between two things is a straight line. This has to be, we're making a straight line. So we are looking for the distance between this point and the point where this imaginary line intersects. Okay? So in order to get this distance, this is the distance I'm looking for, I need to know what this point is. In order to find this point, how we're going to do it is we are going to find the intersection of these two lines. We're going to get a system of equations where we can figure out where this line intersects with this line. Then we'll have this point, and then we'll be able to just use distance formula. So in order to create a system of equations, I need a second equation. I already have one equation, but I need an equation of this line that includes this point. Well, in order to do an equation of a line, we need two things. We need a point. We need a slope. Well, the point we got, 5, 7. The slope is going to be found using the slope that we know. We already know that our existing line has a slope of negative 1/3. Because the line whose equation we're trying to create is perpendicular, that means this slope is the opposite reciprocal. Opposite means change the sign, and reciprocal means flip it. So the slope of the line that we're going to, whose equation we're going to create is 3. And you can see this one goes up 3 over 1, up 3 over here. It looks like a slope of 3. And that's why I kind of tried to make this one look like it goes down 1, right, 3. This is the perpendicular slope. So now that I have a slope and a point, my preferred way to do this is using slope formula. And I know some of you like to do a y equals mx plus b thing and solve for b. That would work for this problem. Wouldn't work for all problems because sometimes you end up with some yucky fractions. But I'm going to use slope formula. So the slope I'm going to put in is 3, or 3 over 1. The point I'm using is 5, 7, so it's y minus 7 on top, and x minus 5 on the bottom. I'm going to solve it as a proportion, so I'm going to do cross products. 3x minus 5 minus 15 equals y minus 7. All right. What's the easiest way to do this? I think I'll get these both to say y equals. So I'll rewrite this equation by adding 7 on both sides. So it's 3x minus 8. Y equals 3x minus 8. So what I have found so far is that the equation of this line is y equals 3x minus 8. And our original line, of course, was y equals negative 1/3 x plus 2. So I'm looking for this point, so I'm looking for the intersection of these two lines. To do that, I'm going to solve a system. My system is going to include this equation and my original equation. Because y equals both of them, I can set them equal to each other. Maybe you've learned the transitive property. Because this equals y and y equals this equals this. Or maybe you're thinking of it as substitution, where I can plug this whole thing in for y here. This negative 1/3 is annoying me, so I'm going to multiply everything by 3 so that I can get rid of that fraction. So this is going to become negative x plus 6 equals 9x minus 24. getting the variables on the right side and the constants on the left side. X equals 3. Take x equals 3, plug that back into one of these equations. How about we plug it back into, we'll plug it back into the original one. So y equals negative 1/3 x plus 2. Y equals negative 1 plus 2. Y equals 1. So what we have found is this intersection point is 3, 1. What were we trying to do here again? We're trying to find the distance between the point 5, 7 and this line. So I'm trying to find, now I have a distance formula problem. I'm trying to find the distance between our intersection point and our original point. Distance formula. Got to stay on the screen here. And so the points I'm going to use, I'll write them over again down here. 3, 1, 5, 7. Here's x1. Here's x2. Here's y1. Here's y2. And I'll math it. Two squared plus 6 squared, 4 plus 36. Simplify my radical. So the distance is 2 radical 10. Thanks for watching. Feel free to watch again or come in and talk to me. We can work on it together. Have a great day.